We're going to start out this section of Boolean algebra and simplification with looking at all the different rules, laws, theorems, kind of go through the examples of solving Boolean equations. So we're going to look at the basic operations, laws, theorems, Boolean algebra. We're going to use some truth tables to prove the Boolean theorems are true, that they actually did simplify correctly. And we need to be able to express our outputs for logic circuit using Boolean algebra. So Boolean algebra is really just a set of laws that are very similar to regular algebra. There are a few differences, but for the most part it's very similar to algebra. You have your cumulative laws, the associative laws, distributive, identity, and complement laws. So let's look at these. The commutative law, Boolean addition, means that you can basically add things in any order you want to. In other words, if we have the variables a or b, we could also say b or a. So we can rearrange those any way we want to. You know, b or a or b. Same thing as in the example down here. I said 2 plus 6 equals 8, and so does 6 plus 2. It really doesn't matter what order you add them in. Same thing goes for multiplication. If it's a and b, it's the exact same thing as b and a. So 2 times 5 and 5 times 2 it still equals 10 no matter which way you go with it. The associative law of Boolean addition means that we can basically group anything we want as long as it's all addition. So we can put parentheses around a or b, we can put parentheses around b or c, or we can get rid of the parentheses entirely and just have a or b or c. So really we can, as long as they're all ORed, that's the biggest deal. You have to be all ORed together or added together to be able to do that. Same thing with multiplication. We hang around the a, b, we can have parentheses around the b and c, or we can get rid of the parentheses entirely and just have a, b, c. So really, as long as they're all the same thing, you can do that. Distributive law, you may remember factoring in algebra. That's basically the same thing. In this case, we factor in, you multiply through the a. So a times b equals ab, and a times c equals ac. So you got ab or ac. In this case, this is a Boolean specific thing, which means a or bc equals a or b and a or c. There are no squares in Boolean algebra, so you wouldn't have, if you multiply these together, you wouldn't have an a squared, you would just end up with an a. That's how this one works. This one doesn't apply math, it's a logic thing only. Identity laws, very straightforward, and I can draw these out in the logic gates too so you can kind of get an idea of what I mean. But the first one, a or 0 equals a. So let's say we have an OR gate, and you got a, and this one's always tied to plus 5, right? So any high gives you a high out. This one's always a 0, so if this was 0, this would be 0. If this is a 1, this would be a 1. So you can say that this just equals a. Same thing goes for, it's not on this page, but we'll hit it in a second, but it's a good time to show it. In an OR gate, if this one is always tied to plus 5, in other words, a or 1, anything ORed with a 1, remember any high gives you a high out. If this one's always tied high, the answer always has to be 1. So a or 1, anything ORed with 1 equals 1. For the AND gates, it's kind of the opposite. If you AND, remember it's anything, you have to have 2 highs to get a high out. So if this one's always high, if you get 0, 1, that equals 0. If you get 1 and 1, it equals 1. So basically the output followed A. If you AND that with 0 or ground and A, if this is always a logic 0, takes 2 highs to get a high out, the output always has to be 0. There's no way it could ever be 2 highs if one of them's always tied to low, so it's always going to be a 0. And like I said, we'll see these two a little bit later on, but I wanted to show you those real quick. Anything ORed with its opposite is always 1. Think about it. Remember, OR gates, any high gives you a high out. Well, if these are complements of each other, if this is 0, that one has to be 1. If this one's 1, that one has to be 0. So one of them is always going to be high. So we know it always has to be a 1. AND gates is just the opposite. 2 highs gives a high out. Well, if they're opposite of each other, I'm never going to have them both being high if they're the opposite of each other or inverse of each other, so it has to be 0. So anything ORed with its opposite is a 1. Anything ANDed with its opposite is a 0. And think of it as just AND gates. Don't think about, and OR gates. Don't think about it as necessarily math. Just think about it as gates. And any variable where I double invert it, like b not, if I invert it twice, it's just equals b. It's kind of like running it through where you've got b, and you got going through one inverter, and then you got it going through another inverter. This would be b naught, and this would be just b. Basically, you're taking away the line, so you just invert it twice. It just goes back to b. So it's a good thing to use when you're doing simplification. And why would you ever do that? Well, if you're solving an equation, you may very well end up with two lines over top of something, and you can get rid of the two lines. Dual property, and we kind of looked at this already in a couple of them, but the inverse of 0 is just 1, the inverse of 1 is 0. We know that. Anything ORed with a 1 is a 1. That's the one I was talking about a while ago. Anything ANDed with a 0 is 0. Remember, any high gives you a high out? Well, that gives you a high out. You have to have two highs to get a high out. You can never have two highs if one of them is always 0, so that's a 0 out. Anything ORed with itself, anything ANDed with itself is just itself. And then anything ORed with its opposite is 1. Anything ANDed with its opposite is 0. And these are all in your lecture notes too. So just to lay this out, let's say I want to simplify this one, and I'll show you in more detail later, but I'm not going to go through all what the laws are that we use, but I do want to show you the step-by-steps later on. But in this case, we've got A or AB. If you kind of look at this thing, we've got two like terms. So you've got A or A. What we can do is pull out an A. So what we need to do is write down the term that we're going to pull out, in this case an A, open parentheses. If you take an A from an A, it doesn't equal 0. It doesn't get rid of anything. It's left with a 1. So pull an A from an A, you're still left with a 1. And or, from the or, and you pull an A from an AB, and you're left with actually 1B. Okay? And then from there, anything ORed with a 1, remember anything ORed with a 1 is just a 1. So anything ORed with a 1 is a 1. Anything ANDed with a 1 is just itself. So you end up getting an A. Now it seems really complicated and crazy and strange, but you'll get the hang of it. It may take a little while. This is probably one of the harder chapters you'll do, but you will get the hang of it, trust me. So why do we do this? Well, sometimes very complex logic circuits can be reduced without changing the function of the circuit. Think about if you had a circuit that had 25 logic gates in it, and you may want to reduce that down to maybe 5 gates. So if you can do that, then you can save the company quite a bit of money. Instead of paying for all these different chips, they're paying for a tenth of the amount of chips that they're using. Fewer gates means less money. The first step's always to write out the Boolean equation, and you have to have that laid out. Next step is apply rules, and then try to simplify it down whatever way you can. Try to remove parentheses and brackets, and then try to find common terms, factoring in and out, and then construct a truth table to prove it. And we'll do some truth tables later on, but right at first we won't. But you usually want to provide truth tables to prove that your original and your simplified are the exact same thing. And then you're going to draw a logic diagram of the reduced expression. Not the original, because it'll be too big, but if you do the simplified one, that would be perfect. So let's look at this one. Let's work this one out. In this case, we've got AB and BC. And if you remember that law that said that we didn't really, as long as they were all ANDed together, we really didn't need parentheses. So we can just write this out as A, B, B, C. We can drop the parentheses. Since it's all multiplied or all ANDed together, we can get rid of all the parentheses. Kind of like saying, we got AND gate, AND gate, AND gate. It's the same thing as saying 1 4 input AND gate. These are exactly the same as each other. So you've got A, B, B, C. Well, anything ANDed with itself, in this case the two B's, is just itself. So we actually end up with A, B, C. That's our simplified. That's as far as we can go right there. To do the truth table, though, we want to do both versions. We want to do the original and the simplified. The original, don't try to do the middle one. Do it exactly like it is right there. Don't do anything different to it, okay? Just do the A, B, and ABC. Let me erase that for you. So I went ahead and did the truth table for ABC, and you can see it starts out, there's 3 variables, so 2 to the third equals 8. So there's 1, 2, 3, 4, 5, 6, 7, 8, 8 lines. First thing we want to do is do the AB, right there. Then we're going to do a BC, BC, and then we're going to AND these two together. So you've got AB and BC. That's the original. So you went up to, on the handouts or something that I give you, do an O just to let me know which one the original is. And this will be the simplified one, is just A, B, and C. So A and B, we're going to AND these two columns together. So we're looking for two highs. Two highs. BC is these two right here. And we're looking for two highs again there. And then we're going to AND these two columns together, AB and BC. And again, we're looking for two highs. And really the only time we have two highs is right there. So that's our original. All zeros with the 1 at the bottom. A, B, and C means we're going to AND all three of these together. So basically, remember, all highs. So we're looking for three highs. And anytime you see a low, it's going to be a low out. So the only time we get one is right there. And are they the same? Yes, they should equal each other. If they don't equal each other, you've got a problem. So we simplified, we did our truth table, and now we need to draw our original, and we can, simplified, and we can just do A, B, and C, just like that. Okay, if you want to keep going with this, spend more time, pause the video, and then go on when you're ready. In some cases, you may ask about order of operations. And remember, it's just like algebra. You do parentheses first, multiplication next, and then addition, which is your OR. So you do parentheses, ANDing, and then OR. So that you do the exact same thing for these. If it does have a bar over top of it, like you have a couple of terms that are knotted, knotted acts as parentheses. So those are grouped together. Those are stuck together if they have a bar over top of them. So remember those. A bar acts just like parentheses. So let's work this one out. So this one, we've got A, we've got a B, we've got an A or AC, and we've got or AB. Well, if I look at this, probably what I want to do is I've got A in three of these, and I probably can rearrange this to pull out an A. So I'm just rewriting it to put all the A's together and stick that B by itself at the end. Next thing I want to do is I want to pull the A out of these. So write down the variable you're going to pull out, open parentheses, and A from an A is a 1. Bring the plus down. A from AC is C. Bring the plus down. And then the A from AB is, you're left with B. I can't pull an A from a B, so close your parentheses and just rewrite what you couldn't touch. So I can't touch B, just leave it alone. Now do the parentheses. Anything ORed with a 1. Anything ORed with a 1 is a 1. So you're left with A and 1 or B. And think about it this way. Let me draw it up here at the top. Some people get confused with the 3 inputs. If I have an OR gate that has 3 inputs, if this one's always tied to +5, and this one's B, and this one's C, well, remember, any high gives me a high out. If this one is always tied to +5, which is the logic 1, my output's always going to be 1. It's never going to change. Regardless of what C and B are doing, if one of those is always tied high, I'm always going to get a high out. And then same thing, follow the rule with anything ANDed with a 1 is just itself. So we're left with A or B. That's our simplified form. So if you look up here for our original, we've got an AB and an AC we've got to do. We've already got A, we've already got B, an AC, AB, and then we're going to OR those three together, A or B or AC or AB. That's our original. Our simplified is just the A or B right here. So let's work through this. A and C is going to be this column and this column, right there and there. So we've got 2 highs gives a high out. So we've got 0, 0, 0, 0, 0, 1, 0, 1. AB is going to be these two. So again, 2 highs gives a high out. right? And then now we need to OR these together. So we're ORing A, this one, B, AC, and AB. So any high in any of those four is going to give us a high out. So there's all zeros. There's all zeros. There's a 1 right there. 1. There's a 1 right there. There's a 1 right here. There's a 1 right there. 1 right there. And a 1 right there. So any high gives us a high out in any of these four columns right here. So that's our original. Now, if everything works out, if we simplify correctly, A or B should be the same thing. So A or B, we're ORing or this column. So any high in either one of these columns gives us a high out. So there's a 0, there's a 0, there's a 1 right here, there's a 1, 1, 1, 1, 1, 1. Are they the same? Yes, they're the same, all the way down. If they weren't the same, first of all, I'd make sure I did my truth table correctly. Usually that's the first mistake people make is they did something wrong in their truth table. If you look through your truth table and that looks okay, then you very well could have simplified incorrectly. So go back and double check your simplification and try not to figure out what you did wrong. You're better off starting from scratch and just redoing it and then compare it to what you did before. It's really hard to look at this and say, oh yeah, I messed up right here, unless you've done a lot of these. So it's best to just start all over again, and maybe you won't make the same mistake twice. So, and then we draw our simplified diagram. It's just an OR gate with an A, B. Okay, let's do another one. I like to throw a lot of examples at you. Here we've got A and A, B, or B in parentheses. And so we need to do stuff in parentheses first, but it's easier for this one if you multiply through to these different variables. So if you take A times AB, and for these, usually the best thing to do is multiply through first. So just to give you a hint. So we take A times AB, so we're left with A, B. Remember, there are no A squares in logic. Bring down the OR, and then we're left with A and B, because we multiply A times B. A and A, anything ANDed with itself is itself, so we're left with A, B, or A, B. And here we've got AB ORed with AB. Well, we've got two variables that are the same, or two terms that are the same. AB OR of AB, we're basically saying anything ORed with itself. AB is getting ORed with AB. So we can just say anything ORed with itself is just itself. So you're left with AB. To solve it, this is our, we need to do just like it is right now. Don't try to simplify it first. Do it exactly like it is. We need an A, we got that. We need an AB, which is right here. And then we need to OR them together, and then AND that with A. So we've got the A. We need to do an A and B, so that we're ANDing these two together. So we're left with 0, 0, 0, 1. Remember, two highs gives the high out. Take AB or B. So AB or B, it's these two right here. We're ORing them. We've got 0, 1, 0, 1. And then we're taking this AB or B and ANDing it with A. So take this and AND it with A. And two highs gives a high. Right? And then actually we already had AB right here, but I went ahead and did it separately just so they'd be next to each other. But if you wanted to write original and simplified, that'd be fine. Either way, it's the same thing. I like to have them next to each other. So you can see they are the same, so we know we simplified it correctly. And do the simplified logic diagram. Again, pause it if you want to go back and look at it, or if you want to do it yourself, you may want to pause it and look away and figure it out, and then come back and double check yourself. I will have some practice coming up for you. Here's another one. We know that anything ORed, we can get rid of parentheses. Well, it's this or this or this. We can drop these parentheses right here. So we're left with A naught B or A or B. Now look for like terms. Be careful. Don't, A naught and A are not the same thing. So we can't pull out an A or an A naught. They're not the same thing. B is the only like term we have. So let's rearrange it to where we have the B's together. Okay? And then we pull out a b, so write down what you're going to pull out, open parentheses, a naught b, and pull out a b from that, you're left with a naught. Draw your plus sign. B from b is a 1, and we can't take b from a, so close your parentheses and write down what you couldn't touch. Go inside your parentheses. Anything ORed with a 1 is a 1, so you're left with b, 1, or a. And then anything ANDed with a 1 is just itself, so you got b or a. Usually you like to put them in alphabetical order, so it's a or b. Either one of those is correct, but this one looks a lot better. Now you should be kind of seeing the pattern here. Anything ORed with a 1, this whole thing kind of just disappears. So you could have just skipped this step right here and went from, okay, that goes away, and we're left with b or a down here instead of doing the 1. If you still need to do that step, that's fine. But just realize anything ORed with a 1, it kind of just disappears because we're left with this b, and we can just write it like that. So if we look at our original, we need an a naught. So I drew an a naught column here because a is not the same as a naught, so we need to invert a. We need an a naught b, well there's the a naught b. We need an a or b, there's the a or b. And then we OR a naught b, which is this column, with a or b, which is this column. So that's there and there. And then the simplified one is a or b, and again, I've got it here. Whatever way you want to do it, that's fine. So a naught is just the opposite of a, so zeros become ones, ones become zeros. A naught and b is these two ANDed together. And again, two highs gives us the high out. A or b is these two columns, and we need any high gives us the high out, so it's 0, 1, 1, 1. And then this is a naught b ORed with a or b, so we're ORing these two columns together, so any high, 0, 1, 1, 1. And again, I've already got a or b. This is our original. Simplified's right here. I went ahead and wrote it next to it just because that's how I like to do it. But you can do whatever. If you just want to put an S under there for simplified, that's fine. And again, the simplified diagram is A, B, going to an OR gate. And that's it. You can pause it, check yourself, go through it on your own. So do this one on your own, and pause your video, and we'll go on to the next slide. Once you're ready for it, just hit play. Okay, there's the answer, and I actually worked it out for you so you can kind of see how I got the answer. I did not do the truth table. If you want to do the truth table, that's great. Just make sure that they were equal to each other, the original and the simplified. So to work it out, you can see we had A, B naught, C, or A, B naught, or C. For this one, we had A, B naught in two settings, and we could have pulled out of C as well. Either way would have worked. Maybe I'll work that one out here to the side if we pull out of C and see how that would have worked. So first, for this one, I pull out an A, B naught, and we're left with a C or 1. A, B naught from A, B naught is 1. This all goes away, and we're left with A, B naught, or C. Now, if I were to rearrange this to pull out a C, it would have been A, B naught, C, or A, B naught. And they'll work out the same. So we pull a C out of this. And we can't pull a C from that. Right? And this all, remember, cancels each other out. So we're left with C or A, B naught. Put things in alphabetical order. And the same answer. So. Alright, practice these. Again, you don't have to do the truth tables. These lines should be up above here. That should be a naught, naught, naught. And ignore these lines right here. And pause it, and you can come back to it. Okay, there's the correct answers. And these are the lines in the correct places. Okay, let me work these out for you just to kind of go through the steps. And I left the answers up here, but for the first one, we're going to pull an A out. So we're going to write down what we're going to pull out. and we're left with 1 or B, C. And anything ORed with a 1 basically goes away and we're left with A. That's for the first one. The second one's a little bit more complicated. The best thing to do here is take the B times the A and the B times the B. So we're left with A bracket, and B times A is AB, or, that's his or, and the B times B is BB. BB goes together as just a B, so we can multiply these through and then we can worry about that. So we take A times AB, we're left with AAB plus right here, and then A times BB is just ABB. And then combine these like terms. So A and A is just AB, and then ABB is AB. Anything ORed with itself is just itself. The next one I'll do right here. We can get rid of these parentheses around the A or B, or A naught or B. We can get rid of the parentheses, so we're left with A naught or B or AB. Two like terms I see here is B. Remember, A naught and A are not the same thing, so let's rewrite it to where the B's are together. So we've got B or AB or A naught. Pull a B out. 1 or A naught, because we can't pull a B from that. This all goes away, and we're left with B or A naught. Put them in alphabetical order. Be nice. Don't have to, but it works better. And then for this one, again, parentheses we don't need around since they're all ORed together. If this had been multiplication there, we couldn't get rid of it. But since it's addition, we can get rid of it. So A or B naught or C, or A, B naught, or C. We can pull out an A, it looks like, or we can pull out a B naught. We'll just go with the A. So rearrange it to where they're together. And you also notice the C or C, well, C or C, just anything ORed with itself is just itself, so we can actually get rid of one of those C's right there too. Now we pull out an A, we're left with 1 or B naught. Can't pull an A from a B naught, so you're left with B naught or C. Sorry, should be or there. So we're left with, this cancels each other out, and we're left with A or B naught or C. And hopefully that helps you kind of work through and see where you went wrong if you've got something different than what I've got.